Could geothermal wells disrupt Earth's magnetic field? We've all heard that geothermal energy is green and renewable, but what if there's a hidden danger over the long run? As we drill into the planet to harvest heat, could we be slowly weakening Earth's internal engine, and by extension, its magnetic field? In this video, we're going to run the numbers and find out if there's real cause for concern. The fossil fuel warning. Fossil fuels once seemed harmless. A little coal, a little oil, no big deal, right? But by the time CO2 levels had risen just 12 to 15%, the climate had already begun to shift. It took decades before we realized how serious it was. Geothermal energy could follow a similar pattern: slow, quiet, and only obvious when it's too late. How geothermal energy works. Geothermal energy works by pumping water into hot rock beneath the surface. The heat turns that water into steam, which drives a turbine and generates electricity. But here's the catch: the process is extremely inefficient. For every unit of electricity we produce, we extract about 10 times that amount of heat from the Earth. Energy per well. Now let's look at the numbers for a single geothermal well. Over the course of a year, one well produces about 44 gigawatt hours of electricity. But to get that, it pulls out roughly 440 gigawatt hours of heat from deep underground. But that's just one well. So what happens when we scale that up over the decades? Projected geothermal growth. In 2020, there were about 3,700 geothermal wells operating worldwide. Based on the best available growth projections, we analyzed three different possibilities. If geothermal scales like past industrial systems, using the CO2 emissions curve as a benchmark at 3.2% annual growth, we'd reach around 87,000 wells by 2120, extracting about 38 million gigawatt hours of heat per year. At 5% annual growth, that climbs to 260,000 wells and 114 million gigawatt hours of heat. And at 10% growth, the kind of curve we might see with aggressive investment in the industry, we'd reach over 1.2 million wells, drawing more than 540 million gigawatt hours per year. These projections show just how big geothermal could become in a single century, depending on how fast it scales. What powers the magnetic field? Earth's magnetic field is generated by motion in its molten outer core, and that motion requires energy. When charged particles move, they do work, and sustaining that motion takes a steady supply of power. That power comes from the Earth's internal heat, the same reservoir that geothermal wells tap into. Scientists estimate that about 2 terawatts of constant thermal power are needed to maintain the magnetic field. That works out to around 17.5 million gigawatt hours of energy per year. Earth's total internal heat flow is about 412 million gigawatt hours per year. We've identified 13% of that total, or 53.5 million gigawatt hours, as a symbolic threshold. That's the same percentage increase where we first began to see climate impacts from rising CO2 levels. If geothermal extraction were to reach this scale, we might start to notice anomalies in the Earth's magnetic field. These three values, magnetic field energy, the 13% threshold, and total Earth heat flow, form a reference frame. They help us understand the scale of energy involved. Are we tapping into trouble? We don't know exactly how much heat we can safely extract from the Earth, but we do know it's not unlimited. Earth is semi-resilient. It can absorb some change, adapt for a while, until it can't. And when systems like the magnetic field shift, they don't always give early warning. Nothing is free. Every watt we take from Mother Earth must come from somewhere. Eventually, if we take too much, something will happen. The only question is, how far are we willing to go before we ask if it's too far? Share your thoughts in the comments. We'd love to hear what you think.